Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 2, the derivatives. This is our lecture number 11. And this is the second part of the chain rule. This is our second video about the chain rule. Okay, so for the first video in the chain rule, we talk about the general chain rule of, like how do we do that? Now for this video, we're going to take a look at how about is involving with the exponential functions. What is the formula for that? But the concept basically is the same, right? You have a composite functions and then how do you take the derivative for the composite function? Okay, now let's go ahead and continue our lecture notes here. Okay, so this is we talk about is for the generalized derivative for the exponential function. Okay, so before we do that, let's start to take a look. From the very, very basic, right? From the first, we said, okay, so we said when the first level, we say f of x is equal to the ex here. If I just have a function of the ex, and then what is my f prime x? So we know from the previous lecture, we know the exponential, we love the exponential function. So it will just be the ex itself here. And now for here, we're going to kind of say, okay, so now if in here we have f of x is equal to the e to the what? Ux, right? So remember when we do the chain rule, so we say, oh, e to the ux. So the e is my first layers, right? And then what happens here? The ux is my second layer. Remember, like we talk about when we talk about the chain rule, it's kind of like peeling the onions here. Okay, so then the f prime x is here will just be, so remember that we said, so this is what is the chain rules, right? So here, this is the e, the ux is here. So this is the ux is here, right? So remember, we use a little table to help us. So the first layer is the e. Then based on what we did before, so will just be the self, is the ux, right? Then the next layer is the ux. Then we know the derivative of the ux is what is u prime x here. Then what do you need to do here? You multiply them together, correct? So what is the, based on this ones here, will just be the e, the ux times the u prime x here. Okay, so this one is very easy to show. Now, how about if right now, let's see here, if my f of x is here, is n, is any constant like the a to the what? A to the x is here, right? Okay, so of course here the a we say has to be greater than what? Greater than zeros, right? Okay, so now if in here, take a look here, right? So for the formula we did before, my base is a very special base. It's the E is 2.7124. So how about if I have any, like any basis here? So what is my f prime x is here? So the formula for the f prime x is just like we did before. So it will be the ax is very similar like in here, right? And I need to adjust constants. So I need to do the natural log a. So the same way is here, if your f of x is equal to the a instead of the ux, instead of x is here, then the f prime x is the same, it will just be the a, the ux, then you use the chain rule u prime x, and don't forget you need to adjust the constants times the natural log a. And I want to, so why the formula is look like this, right? So that's why you need to be careful. Don't forget, you need to adjust constants. I'm going to do a very simple way to show you why. Okay, so now let's use the easy ones here, right? So let's say the f of x equal to the a to the x here. Okay, so now let's take a look here. The a to the x, I can change. This is a to the x. This is e natural log ax, correct? Because I know, I know the e and the natural log, what happens here? They are the inverse function. So basically you can treat, you can treat like these two cancel each other out. That's why you have the ax equal to ax, right? So I can treat this is the e to the natural log ax here. Okay, so now I can write my functions here is e, okay? So I can write my functions here is equal to e, the natural log ax here, okay? So then in here, I can, what I can do here, I can say, hey, this is what? This is my ux here, right? So now you go back to this formula, the e to the ux. Okay, now let's take a look here. The f prime x here, based on what we did here, will be the e to the ux, right? So the ux here, so e to the ux. So this is a natural log a to the x, right? So this is the ux, right? Then I need to times the u prime x. Okay, so let's take a look at what is u prime x here. So the ux here, we say is natural log a to the what? To the x. Then by the log rules, you can move by the log rule, you can move these exponents to the front. So it will be give you x to the natural log x, natural log a, right? Now you take u prime x. So what is u prime x will be the natural log a here. So now this one here is will be times natural log a. So what is natural log a here? Natural log a, this is natural log a. So this is u prime x, right? And then the same ways here, if you take a look at the ux, this part, e and the natural log, they are the what? They are the inverse function. So now these two can kind of, you can treat it as kind of like they will be able to cancel each other out, right? So what is the final answer? So you will have ax times the natural log a, right? So that's how does this formula get here, all right? So that is our, how do we do the exponentials here? Okay, so be very careful. If the base is not the e, the 2.712, is that irrational number, then you need to adjust, right? So you need to adjust the constants. Take a look at the natural log e. Okay, so now let's take a look here. All right, so the first one's here. Let's take a look at how do we do this one. So this is f of x is e to the 4x plus 7. So immediately you see this is your first layer, e, and what is your second layer? 4x plus 7, right? So if you want, or after a while you are getting familiar with, you don't need to use this table anymore. So this is a 4x plus 7, this is a 4x plus 7, right? So you highlight it, so you say this is my first layer, and this is my second layer. Now you take the derivative. So the first layer is e, will just be itself, it's 4x plus 7. And then the 4x plus 7, you take the derivative will be what? Before, then you times it. So what is the final answer? This will be e the 4x plus 7 times what? Times 4, or you rewrite it into a better form, is the 4x plus 7 here, okay? Okay, now let's take a look at this ones here. So this is e to the square root of x, okay? So this is the e to the what? X to the what? 1/2, right? Square root is 1/2. So it's the same thing, the e is the first layer, And this one is the second layer. So let's use the little table to help us. So we'll see here, this is the e to the x to the 1/2, and then this is x 1/2. Now you take the derivatives, right? So remember, I'm only dealing with the e's here, right? So the e, the derivative will be itself. So it's e to the x to the 1/2 power. Or if you want, you can write it back to the square root of x. It looks better. Now you take the derivative of your second ones here, right? So make sure you do color coding. So now you are taking the derivative of the x to the what? 1/2. So you use the power rule. So this is 1/2. Then x equal to the 1/2 minus 1 is equal to negative 1/2. So you will see here, this is 2x1s, right? Now what do you need to do here? You need to multiply it. So what is the final answers here after you multiply it? So the f prime x are going to be, so I should say this is the f prime x, right? So this is f prime x. So the f prime x will just be the e to the square root of x times the 2 to the square root of x1. So if you want to simplify a little bit, you can say f prime x, or looks a little better, you can say it's 2 square roots of x, the e the square root of x, like that. Okay, now let's take a look at the next one. Oh, the next one is e to the 4x. So you say, oh, here is not the e, so we know what is the derivative here? Will just be the self, right? Because this is not e, so what do we need to do? I need to times the what? Natural log what? Natural log 4, right? Don't forget, I need to adjust the constant. Okay, now let's take a look at these ones here. This is f prime x here, right? Okay, so these ones here, you say, oh, okay, so this is my first layer, and then this is my what? This is my second layers, right? Because it's not an x anymore, it's a function, right? Even it's a very easy function. So you say, okay, so the first one is 3 to the negative x. Okay, and then the next one here is negative x, correct? So this is my first layer, and this is my second layers, right? Okay, so remember, right? So the first layer, you take the derivative, will be itself, but since this is not a 2.7, so what is here? Times the constants, right? And this constant is natural log a. So what is a here? A is 3. Then you take the derivative of this one is what? Is negative. Then you multiply that, right? So now f prime x is equal to what? Is negative natural log 3 and 3 to the negative x, right? Okay. All right, so now let's take a look at this one. You say, oh, this one. This is the what I have here. I have one function. I have another function. So what rule I'm going to use here? You product two functions. So what I'm going to use the product rule, right? So I need to apply the product rule. So f prime x will be, take the derivative of the first one. Oh, first one is 2 to the x. So the derivative will be what? Will be itself 2 to the x. And because of the base is not e, what I need to do? I need to times the natural log of what? Natural log 2. Then you need to times the second terms on change, x squared plus 1. Correct? All right. Then plus you hold the first one, you take the derivative of the second one. So x squared plus 1 is what? It's 2x here. So if you want to color coding that, so this will be the corresponding to the derivative of the purple. And this things here is corresponding to the derivative of the blue. Okay, so if you want, you can, if you want to, you can combine a little bit. Let's see anything we can combine. Yeah, you can take the 2x out, right? And then here, this is natural log 2, then the x squared plus 1 plus 2x, right? Okay. So now let's take a look at the part F. So here's the same. I have a function here. Now I have another function here, right? So it's e to the x squared e to the ex. So what rule I need to use first is the product rules, right? Okay, so the product rule, okay, so f prime x. So I'm taking the derivative of the first one. So the blue one, so will give you a 2x. Now holding the second one, not change. Then plus the derivative of the second one. So it's cosine ex. I'm going to do the cosine ex here. So what is the first layer of my onion here? It's a cosine, right? Because the cosine function. Then what is the second layer? It's ex. All right. So now let's take a look. Yeah, so I put this is a cosine ex. I peel the first layer of the onions, then I got the second layer, right? So if you're color coding that, I would probably will help you to take the derivative. So what is a cosine? Negative sign, then the ex, right? So what is the ex? Will just be the self, then you multiply. So now in here you have negative e to the x sine ex here. Okay, so now this will be the 2x cosine ex minus x squared e to the x sine ex. Anything I can simplify a little bit? Not much. I can take the x out. So this is a 2 cosine ex, right? Then minus x ex sine ex. Okay, so if you want to color code a little bit to help you to understand the product rule, so the 2x is the derivative corresponding to the blue one. And then in here, this is the derivative corresponding to the purple ones here. That's how do you use the product rule. Okay, so that's it. That's it for this video. It's a very short one. So basically we talk about is the derivative formula for the exponential functions, right? So you need to remember if the exponential function with the base is e, what is the formula? If the base is not e, it's the number a, so could be any number. The a has to be greater than 0. Then you need to what? You need to do a constant adjustment, right? So you need to take the natural log a. All right, that's it. Okay, and so I guess that's it about this lecture, and I'm looking forward to talk to you for our next lectures here. Okay, bye.